The APAS system consists of number of modules: capturing, trimming, digitizing, transformation to create a 3D, filtering to filter digitizing error, displaying, and other modules that will be discussed later. The first process in motion analysis is to capture data, video data. And there are two methods of doing it: using markers for automatic digitizing and using manual digitizing, especially when there is no choices to put markers on the outlets. In my example first, I'll use the manual digitizing with on Olympic athletes, Discus thrower, that we did the project in the USOC in Chula Vista, San Diego. In this case, we have three views. Here is one view. Here is the second view. And here is the third view. As one can see, they are not sequenced correctly. So in this case, we have to trim the video in order to synchronize it, so all the three views will be synchronized. To synchronize the three clips, we are using the trimmer. We'll upload the original three unsynchronized data, and then we'll try to trim it. So for that, we click on the trimming, and we have the screen to upload the three videos. So here is one video, then the second video, then the third video, and if we go through the sequence, one can find out that since we couldn't touch the outlets, and we couldn't put markers on the outlet, and we couldn't have any wiring that going between the cameras, each sequence has its own independent run, and when we will see that the outlets release the discus, in this case he released it already, here he didn't release it yet, and here he didn't release it. So we want to synchronize it, and we'll synchronize it on a frame, particular frame. So I'll go now to the frame where he's released the discus, and we can go frame at a time here. We'll decide that in this sequence, here is the synchronize. Push on the synchronize signal here. We continue to go forward, and we find out that he released the discus right here. We synchronize that, and we'll go to the third sequence, this one. So now we have three sequences to synchronize, and instead of having a frame, we'll go to time. So now when we'll go to the release, we'll find that the all will be synchronized, and if not, we will make an adjustment. So we'll go here. Here you see sync, 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 and maybe here we should go another frame. So I'll go one frame forward. That looks a little bit better. So now the synchronize. The next thing we want to find out, how much we want really to digitize. We don't want to digitize the whole sequence. In fact, the first sequence starts too early. And if we go forward, you see the other sequence appear. So since now they are time synchronized, let's decide at what frame we want to start the analysis. And in this case, I'll do an arbitrary decision. Just when you take the arms back before we start turning, I'll decide that from here, anything before that will be cut out. And now we'll go to the release. So we'll go all the way to the release. And we'll go a little bit after the release, and we are not interested after here. So we'll cut everything out there. So now if we go to the beginning, we have 3 videos which are correctly synchronized. I'll go all the way to the release again just to make sure. Here they are releasing the Discus. In this case, we synchronize it on event. We can also synchronize it on time that initiated by light or sound, anything that, or dropping ball which is hitting the ground, which will be another signal. Any signal that you can see in the three views. So this is the process of trimming. After the trimming is done, then we're going to the digitizing modules. We click on the digitizing, and here we have the digitizing screen. We'll go to a file and we'll start a new project. We'll call this project Yarn 4. And we will say, okay. Now we have to input few parameters. The title, that will be Yarn 4, of course, or any other name. And what the units in centimeters, or we can have it in meter and kilometer and inches, when we will stay with centimeters. How many points? We'll have certain number of points on the body. Also, control points are for the calibration frame. How many points on the calibration frame to get the 3D. The type, it's either system or user defined. The name of the segments and so on. The height of the person and the weight. Now, since I don't remember exactly what are the parameters for this particular outlet, I'll read it from a previous file that this project was done. In this case is Yarn Demo 2. And here we have his name. We have 19 points. He weighed 285 pounds. The points ID are, the point we're going to digitize are the foot, the ankle, the knee, the hip, the foot, and so on, including the discus. We can have more points if we want. We have a control points. These are the calibration frames on the field, which is a certain structure that we have to capture also in order to input it for creating the 3D. So if we say OK, it asks me how many cameras I use, and I have 3 cameras. So I'll select the different views. So the first trim was here. The second trim was the back march. And the third one, which called the back side march. So here I have the 3 files from the 3 cameras with the proper video. If I say OK, here I see the 3 views of the athletes. And we have to digitize the points for every particular one. I'll go a few frames forward. I will not waste time in digitizing all the frame. I just will show how we're doing it on one frame, and that's how we're doing it in all the other frames. So you see how it's moving in sequence. So I'll select particular view. Let's take this view from the back view. We'll make it a little bit bigger. And it tells me to digitize the fixed point. I need some fixed point in the area. I'll select this one. So everything is relative to the fixed point. Then tell me to the right foot, right ankle, right knee, right hip, and then the left foot, left ankle. It's all tell me here how to do it. We'll go to the left knee. You see it's automatically connected because it's the standard model of the person. Tell me to go to the left hand, left wrist, elbow, shoulder, and then the right hand, right wrist, elbow and shoulder. Again, it will connect it. Tell me to go to the chin and the forehead and the discus. So this is frame one. It takes a long time to do it because we don't have markers on the body. I'll show you later on with markers how fast it's done. But if you put markers on this athlete, you will not show the discus the same. So we'll go to the next frame. And it tells me that I didn't do the other views, and it's true, but I'll go anyway. And now it will assist me. It already remember the previous point. So it's much faster. Left ankle. And the hand, elbow, shoulder, hand, wrist, elbow, shoulder, and forehead, and the discus. And you go to the next frame, and so on. You have to do the whole sequence. So right now, I have all these 3 sequences, but I only did 2 frames for this particular one here. Here you see how the digitized look. But if I'll select now the project that all this thing was already done, I'll go out of here and go to the digitizing, and I'll open the project that already was done. You'll see all the 4 cameras that were used, and they already digitized. So here you see every single frame digitized. So this is the process of digitizing. After the digitizing is done for all the views, 3 or 4, depends how many cameras you have. It's 1 view per camera. You need minimum 2 views for 3D, but 3 cameras views are better. Then you need to transform the data. Transformation, which is the direct linear transformation, it's called DLT, is done by the transformation modules. So if I click on the transformation modules, I'm getting the transformation screen. Here is the transformation screen, and we're going to load the file that we just digitized. It tells me that it's already done, but I'll redo it. And here are the 4 cameras, but I'll select like 3 cameras. You can select any cameras you want. Since we digitized only 3 in this demonstration, I'll select only the 3. And you just set 3D or go. You tell me here that the rate is 59.9 or 60 frames per second. So OK. And the process starts. And the transformation is done. After the transformation, we can check the raw data first. We go back to the basic module. And since we already did the trimming, the digitizing, transformation, let's go to display. Before we even smoothing the data, before we filtering the data, let's go to the display first. Here is the display screen. And in the display screen, we are going to load a 3D file. We'll go to the one that we just did the DLT on it, transformation. And we select a new 3D. In this case, you see the only data we have is the raw data, raw position. So let's take, for example, the discus, which is one of the points that we digitize, and we look on the X, Y, and Z coordinates. We can graph it, the data. You can select the proper parameters here, which I'll not go into detail here. And here is the data for the Discus. We can select also here the stick figure, and we'll use it in a tile mode, so we'll see it both. And then if we can let it go for every position here, and you see that it's still jiggling. And the reason is that it was not smooth. And you see also in the data here, there are some digitizing error. It's not very significant. However, we would like to filter the data first before we looking for the results. We can put also the video here. I'll go back and we'll select the video. So one of the trim video, and again we'll go to the tools, to the tile. So now I have all this data together, and that's without smoothing. So even though he is smoothing in his motion, you'll see that this one is not very smooth. We got to filter the data. To filter the data, we push against the filter, and that will open the filter screen. Here is the filter screen. We'll open the data that we transform, and right away you see the X, Y, and Z of every segment. In this case it's the foot. We'll go to the next one, is the ankle, and you see there are variation between the raw data. You always see the raw data versus the smooth data. In this case it's over smooth. So we have all kind of algorithm to take care of that, but here manually I can change it. If we take even this segment, which is very well smooth, but if we'll unsmooth it, it looks the same. However, if I'm going to the acceleration, look how much noise there. Also, you see on the power spectrum here, a lot of high frequency. So we always have to remove the high frequency to create the real data. Same thing to do it on the Y coordinates and the Z coordinate. I will not spend a lot of time here on the filtering. I'll go back to the position, and automatically will filter all of them. We'll have another time discussion about the filter module by itself. So that's the end of the filtering, and now we can go back to the display to see how it affects the display. So I will stop it here, go to the display, select the data that I just smoothed, and this time I see a lot of data here: linear, segment angle, joint angle, length, segment linear. In this case, I'll take the linear velocity of the Discus and few other parameters, like I select the left foot, left ankle, left knee, and left hip. And I'll do it in 3D. Now we have the 3D because we filtered the data. And if I will plot it, here it is. We'll take the stick figure. Here it is. And now put it on the tile. And we can correspond every position. And you see it's much, much smoother here. And if I'll stop it just here, you'll see that at that point, he's bringing his front leg, these are the front legs, to abrupt stop. If I go frame by frame. So at that point, he should come to exactly on the ground, and that would speed up everything else, including the Discus. Unfortunately, he's leaving the ground a little bit too early. But we'll not analyze the data now. I'll bring some video also to the play here. So that will be the trim one. And Actually, I'll select the proper file just by going out, go to the display again, and select the proper directory, which was the Discus. I'll go to the 3D and I'll go again linear velocity of the Discus, and I'll take the left foot, left ankle, left knee, left hip in 3D. I'll graph it. I'll select the stick figure, and I'll select some video files that corresponding to this particular action. Here is one. I'll select the other video file, another view, 2. I'll select the third one. And even though there are 4, I'll just select 3. Well, I'll select 4. I'll go to the fourth one. Hope we have enough room on the screen. I'll tile them. Yep, everything's fine. So here I have the data and the stick figures and all the view. Now you see the whole motion. So the coach now can interpret a lot of data. In this case, just velocity of the discus and the front leg. We can go also here to every point and see the position of the discus thrower at this various position. We also can make a numerical analysis by adding a table, and if we go the whole motion, it will actually give you in any place, it gives you also the numerical data. I can stop it in every point and going to every position, and that changed the corresponding stick figure, the graph, and that give a lot of value to the coach that wants to learn about this movement.